Hi, my name is Ian Boggs and I'm the suspension team leader this year. Our design goals this year, we wanted to further optimize Panther's design that Tim had done, but also last year we found that there were some problems that we needed to fix. Some was the rear toe issue, the spherical bearings, drivetrain for sprocket adjustment, and then we're also looking at eliminating a pull rod in the front, and we want to get a lot of testing done. Panther's design, the stuff we liked was the removal of the rear box. We got rid of a lot of extra weight and it made packaging and suspension a lot better. We also got to optimize the roll pitch and yaw, lower center of gravity, and we also have a 3D kinematic model of the car, which we are able to see. We're able to see what the car is going to do in any sort of roll, pitch, or yaw, bump, travel. Another thing we wanted to keep was the adjustability of the car, because overall that's how you're going to tune the car to be able to dial it into what you want and try out new things. The rear toe, this was the new upright that I came up with. What it basically does is it moves the A-arm and tow bar far away from each other. The reason it was done close together last year was due to packaging and it saved weight, but we found out that the slot, which it only takes a few thousandths, in either the tow bar or the toe mount or the A-arm mount, the wheel is able to move a lot more than when it's spread apart due to the moment that the tow bar is allowed to handle. And then my uprights, I increased stiffness, and I did gain 0.8 pounds overall, but I was still a full pound lighter than Puma for those uprights. And
what was the stiffness for your displacement or max load?
The deflection of Panthers was 30 thousandths. Mine were 22 for those. Deflection. And I increased the factor of safety on that. For the spherical bearings, this was the other problem we had at competition. We had a problem with the chamfer. We found out that it's very important to have that 30-degree chamfer in there to make the right seal for the staking tool. And then another thing we found out after we fixed that was the axial loadings that our car sees on the track and in transportation with the trailer. So that's where we started to look for new spherical bearings. We've always ran the narrow ones in the past, and we found the wide ones, which have axial loading 4 times as much. And we do lose a little bit of radial, but it's not much. It's already pretty good. And some of the design issues with these that we have to overcome is that since these are wider, our bearing retainers also get wider. And we also moved to a smaller A-arm tube due to the loadings of the sides of the car. And we're going to see how all that works out. So I didn't put a picture of those on here. Drivetrain adjustments. In order to keep the adjustability within a sprocket and seeing what we can do with the car from track to track, the diff needed to be moved back from the rear of the car, which also moves the wheel hub for the half shaft, which moves the tire contact point. What that creates is a longer car, which I also wanted to move towards because driver feel of the car, with as much power that Eric's looking to make, I think really nice to have. And it also, without having the rear box, we only have a minimal weight increase from that. I mean, only a few things, a few frame members are getting longer and a few items are getting longer. And also by making the frame larger, we had more space for packaging inside the car. Eliminating the pull rod. This is something that we were researching and we found a push rod will take almost all the resultant load, which leaves all the other suspension members other than that push rod. Leaves them with no load, which makes them just inherently more stiff. And that adds to overall stiffness throughout the whole suspension setup. Whereas a pull rod, you're pulling on all those components, and you have a lot of deflection in unknown places due to unknown loads. Also, for design characteristics for the frame or monocoque, the upper A-arms and the push rod, the forces that they put on the frame are generally very light. And since we can't have members in the frame go to the driver's legs, this helps for frame design because the loadings in the upper A-arm of the frame, they just aren't as much. Which is where there's a problem with the pull rod, because the pull rod also adds a lot more forces to the upper A-arm. The big thing we wanted to accomplish this year was testing. At the beginning of the year, we bought a program, Optimum K, and what this allows us to do is to go in and pair up all the points of our design for our car inside this program, and then we can either design a set track for us to go in and see suspension movements and how the geometry of that car interacts with the track and yaw, pitch, and roll. And we can also upload data log runs into that program, and so we can actually see, like, if we got data testing from Panther at a certain track, we can see what Lynx's geometry design will do at that track without having the car actually built that.
What was the results of what you've done thus far, Optimum K?
I only have Panther modeled right now, and I don't have a very good data log run for Panther, so I haven't gotten any major results from Optimum K yet. And then another thing that we'd like you to do is a better use of resources and time at any events we go to, mainly SCCA, people there to do tire temps and tire pressures and seeing what minor adjustments do on the track. I also would like to fully test a set of Goodyear and Hoosier tires for us to know which is better in all sorts of different parameters, like concrete, temperature, stuff like that. Another thing with tires is I don't think that we have ever properly broke them in the past, or I know we haven't taken very good care of them, and that list is a pretty big one. Tedious, but I think it'll help us in the overall. And all this testing will lead to more drive time and driver experience inside the car. It'll also make the car better, which is ultimately what we need in competition. Any questions?
Ride height?
Should be about an inch.
It's two.
It's two.
Well, it depends. Depends how low the diffuser sits.
So,
How low can I go?
No lower than an inch, because you have to have an inch of play.
You can't bottom out either.
If you scrape, you're disqualified.
No.
If you hardcore scrape,
Hardcore scrape.
it's up to the judges. Due to ride height and stiffness and roll, I was planning on tuning Lynx as is, and then once arrows added, we're gonna have to go from there, just to ensure that we have our mechanical grip for grip.
what camber are you running front and rear?
I'm pretty sure, as of right now, what Panthers was, which was 2-3 degrees.
25 degrees, yeah. Is Matt, can you talk about the rear spindle?
Yes. And I think the only thing I've left out for the most part is anti-roll lowers, and I'm still looking into how I want to run those.
What are we shooting for like rear to front weight bias? Doing reading 53 rears, optimum, but with what we're doing, you know, it's kind of hard to get that much rear. What are we doing to
I
try and
think
improve that?
if we try and design for 60, due to trends in the past, designing for 60/40 might get us to that 53/47. I don't know how it's all going to play out with the lighter engine. We did move the driver back.
Significantly. Alright.
How are you gonna adjust from aerodynamic oversteer, understeer?
Just the adjustability from the car itself. We have a very wide range of camber and shocks. The shocks themselves are very adjustable, not to mention the springs.
Okay, my question more, what would be your first thing to, like, if I'm a judge and I ask you, like, how are you gonna change, like, what's your first adjustment to make? Is it gonna be your springs or is it gonna be camber?
I'm not sure.
You'd have to look at the data and figure out look at your tire temps and.
Just something to think about.
I mean, that's what the testing's for. I mean, we'll be able to know what we want to change.
Yeah.
Just depends what the car's doing.
Mm-hmm.
Track speeds, but if it's a slow track, anything else?